brought you to this place? Because I have something very important to tell you. Let's talk about microcontrollers. We're doing something a bit special in this new series of videos, and we're going to be having fun with microcontrollers. So please join me in today's video where we'll do a short intro on what the project will be about, and then we will look at the kind of board that we are going to use, how we are going to program for it, and how we are going to set up an MQTT broker in a Kubernetes cluster in the cloud so we can publish and subscribe to it and send and receive messages. So what we are going to do for our small project is have a temperature and humidity sensor connected to this microcontroller board and have it send its readings from the outside world to an IoT. On that IoT, we will be setting up some alerts and rules in case the temperature gets too high or too low. So let's get started. So the board that we are going to use is called ESP8266. It is a board that has a Wi-Fi module included, so we can use it in IoT projects. The first thing that we need to do in order to connect to our board is to install the Arduino IDE. We can find that on the Arduino official page. And if you want to use Visual Studio Code to write your code and upload it, we need to download version 1.8. Otherwise, you can use the latest version 2.0. I've chosen ESP8266 because it provides a highly integrated Wi-Fi system on a chip solution. It's got a complete and self-contained Wi-Fi network function, which can be applied independently or can run as a slave for another host MCU. So for the MQTT broker, I have chosen Mosquitto. It's from Eclipse, and it's my favorite one to work with. Totally open source, so that's what we're going with. In this project, we will implement connecting the ESP8266 port to an MQTT broker that is running on a Kubernetes cluster. MQTT is a lightweight and flexible protocol to exchange IoT messages and to deliver data. Let's also take a quick look at how to set up Visual Studio Code with Arduino IDE so we can use it directly from there. In order to set up the Arduino IDE to function in Visual Studio Code, first of all, we need to install the Arduino extension. And then, using this extension, we can configure everything as if we were using the Arduino IDE. Selecting the board config command allows us to configure our board, and here you can see what I have set up for the ESP8266 board. Now, for the Kubernetes cluster, I'm going to use the one available in Oracle Cloud Infrastructure, and let's take a look at how we set up, create a new cluster, connect to it, and then deploy Mosquitto. In order to deploy the MQTT broker, I've chosen to do it on a Kubernetes cluster running in Oracle Cloud Infrastructure. And here we can create our cluster. You can see that I already have one for the purpose of this exercise. But if you want to create a new one, you can choose either Quick Create or Custom Create. I recommend using Quick Create because it creates all the resources that you may need, including the Internet Gateway, NAT Gateway, the VCN, and so on. We can check the status of our cluster. Of course, I have chosen a public subnet for the services, so we can access the Mosquitto broker directly and not through a load balancer. You can click on the Quick Start option in the resources, and then once you click on Access Cluster, you will have the option to do it from your Cloud Shell or locally. Let's take a look at how to deploy Mosquitto on a Kubernetes cluster with Helm. So here I have the Helm chart downloaded. And the only thing that I've changed is that I've added a username and a password in the configuration. So let's take a look at how we deploy it. So in the Helm install command that we will use to deploy our Mosquitto broker to the cluster, we need to set the persistent storage class to OCI, persistence true, and then the service type as a load balancer. And then we can generate the name and use the namespace that we have previously created. Once the command has finished, we need to wait for a bit for a public IP to be assigned to our new Mosquitto load balancer. And once that is done, we can connect to it using, for example, MQTT Explorer. You can install MQTT Explorer from the App Store. In MQTT Explorer, we need to set our protocol. We will be using the MQTT protocol. the host and port, and then the username and password that we will be using. And as you can see, we have successfully connected to our broker, and now we can publish messages and subscribe to topics. And now let's take a look at the source code on the microcontroller side. So let's look into the sketch and see how we have defined our pub sub client. First of all, we import the libraries ESP8266 Wi-Fi and then pub sub client. And we also import our definitions of the username, password, and IPs and all of that for Wi-Fi and for the broker. The pub sub client library enables ESP8266 to connect to any MQTT broker to publish messages and subscribe to topics. We will open a serial connection for facilitating the output of the result so we can check it in the terminal. Then we set the definition of the MQTT broker, we write the callback function and print the connection information on the serial monitor. After successfully connecting to our MQTT broker, ESP8266 will publish messages and subscribe to the topic that we have selected. Then in the callback function, we print the topic name to the serial port and then print every received message. And now for the most fun part. Testing! So let's connect our board and send a test message. If we use MQTT Explorer to publish a message to this topic, we can check and see that our client, which has subscribed to this topic, received it. My cats and I thank you very much for joining us in this video. Hope you had fun with it and join us in the next one, where we will take a look at how to install IoT in the cloud and how to connect our MQTT broker to that IoT instance.